All right, here is our video for the section called 1.2a field properties. And notice this announcement on top in the red letters that you have a quiz this Friday. It's going to be over everything we've done this year, including today's lesson. So everything from last week and then everything from Monday and Wednesday of this week, okay? And if you have your notes printed, go ahead and grab those. If you don't, look at them on your device. Make yourself a rough table that looks like this. This is the notes, the table from the notes. Pause the video and take a few minutes and either find your printed notes or get your table set up and then come back to the video. Okay, what I want you to do first is this column right here that's called our casual definition. I want you to go to an online dictionary and find definitions for these words that are all the way here down the left. And I don't want a math definition. Okay, you'll find a math definition. I don't want that. I want you to find like an everyday common casual kind of definition and go ahead and write that in this column here, the one, our casual definition. Take a few minutes and pause the video and fill out all this all the way down to here with the definitions that you find. All right, here's some definitions that I have that are casual that I collected from students in the past. Some definitions that we've come up with, the word for commutative means to exchange, to change something out, to commute it. Associative, an association of things that are associated together. Identity, that's what something is. And inverse, a casual definition for that is opposite. And then for distributive, a casual definition we've come up with over time that, and again, these are all things I have written down from past students. If we were in class together, I would give you time to come up with these and we would talk about what you came up with. Giving out evenly is a way of thinking about distributive. And the reason why I wanted you to take some time to think about what these words mean in regular conversation is because I want you to use those as an association for the math definitions that I'm about to give you. So that's what I'm going to do in these next two columns. You'll see they're both titled Mathy Definition. One column, though, is what those look like for when we're adding, and the other one is what it looks like for when we're multiplying, because it's a little bit different. So the Mathy definition that I want you to write down for commutative, we're just going to use variables, but remember these represent numbers. I'm going to write it down and then talk about it. So the commutative property for addition says if you have two numbers A and B, it doesn't matter the order that you add them in. So A plus B is going to give you the same answer as B plus A. And if we just pick two simple numbers to show that, we know that 2 plus 4 gives me the same answer as 4 plus 2. The order that I add them doesn't matter. And if I had multiple numbers, like if I had 3 things, A plus B plus C, and if I picked any 2 of those and added them, it doesn't matter which order they go in. I'll still get the same answer. Remember, order of operations, you do parentheses first. So if I did B plus C on the left, then added it to A, it would give me the exact same answer as if on the right I did C plus B first in that order, and then added it to A. And so what I really want you to take home here is that when we're talking about commutative property, the order doesn't matter. When you're adding. And it also doesn't matter when you're multiplying. So for example, if I had two numbers A and B, A times B is the same as B times A. So like 3 times 5 gives me the same answer. And same thing if I had three numbers. If I did A times B times C, I'll get the same answer as if I switched B and C. Okay. Or I could have switched A and B or A and C. The order doesn't matter, you'll get the same answer. Now for the associative property, which is our next one, what's happening there is that the grouping doesn't matter. And one way I like to help students remember what associative means grouping is like if you think about if I have a friend group, right, that are my closest friends, they are associated with me, right? They're my associates. People know that we're friends. They associate us together. They're my friend group. So associative property means grouping doesn't matter. So associates is your group. That's one way of remembering the difference between commutative and associative. And so that would look something like this. So in order to talk about grouping, we need, it doesn't work here to talk about just two things like we did above. We need at least three things to talk about different groups. So let's say I had three things that I'm adding, A, B, and C. So notice the order is exactly the same. Okay, the order hasn't changed here like we did above. Excuse me. What we're going to do is just group things differently. So if I group A and B together on the left, it would give me the exact same answer as if I grouped B and C together on the right. That's associative property for addition. And the same thing is true for multiplication. If I had A times B times C on both sides, so notice the order is the same. It's different from the property above where we switched the order. Order's the same, but if I just change the grouping, if I grouped AB on the left and BC on the right, and then followed my order of operations and did that math, I'd have the same answer on either side. So for associative, grouping doesn't matter. For commutative, order doesn't matter. And grouping for associative, order for commutative. And one way I tell students to remember that commutative order is I talk about how my house is in Bulverde Village. And if I'm trying to drive to Johnson, I can go two main ways. I can go from my house past Cibolo Green and turn onto TPC Parkway. Okay, that's my commute to work. You see where I'm going with this, the word commutative for the property and my commute to work. Another way I can go is take a right at the park, go out the main entrance to the neighborhood. You know where that lighthouse is on Bulverde Road? I can take a right there and then take a left onto Bulverde and then get to Johnson that way. Now the order of my commute doesn't matter. I end up at the same place. So commutative, like my commute to work, the order doesn't matter. I end up in the same spot with the same answer. Associative, like my associates are my friend group, grouping doesn't matter. You end up with the same answer. And this is true for addition. We have addition property and a multiplication property. For our identity property, for addition and multiplication, so the idea of identity, we wrote for our casual definition, it's what something is. And so for addition, if I'm starting with a number, let's just have some random number A. What do I need to add to it so that the number stays the same and it still is what it is? What number can you add to any other number that keeps it the same? 0. Right? So this property says if you add 0 to anything, you get that number back. You get it, what it still is. Okay, this body is toxic too. Adding 0 to any number results in the answer of that number. It stays the same. Take a second and just think about what that would look like for multiplication. If I have a number A, what do I have to multiply it by so that it still is what it is? And its identity remains the same and it hasn't changed. What number do you have to multiply it by? 1, right? So that's our identity property for multiplication. Now, our inverse property, we said inverse is opposite. So let's think about that. I'm going to set this up like I did the identity. A plus what would have to give me 0? The opposite of A. I'm going to write it like this, the opposite of A. That's our inverse property for addition. If you add something to its opposite, you get 0. This property we use when we're solving equations. Like if I had, I'm going to come over here, like if I have x plus 5 equals 7, and I want the x by itself, well then I want x plus 0, which is still x. So I add the opposite, which means subtract. And I know that when I add the inverse to 5, it cancels out and leaves nothing. And this property tells me I can do that. Think about for a second, what do we have to multiply things by to get to cancel it out? So for adding, we just add the opposite and it cancels out. When we're doing multiplication and canceling stuff out, that doesn't leave us with 0. That leaves us with a 1. So back over here, like when I did this example in the screen, I was adding the inverse to cancel it out. If I had an equation like that, where it was something was being multiplied instead of added, like let's say I had 2x equals 8, and I wanted to get rid of the 2. It's x times 2. How do I get rid of the 2? I divide both sides by 2. What I'm really doing is multiplying by 1/2. Multiplying by 1/2. So to undo 2, I have to multiply by the reciprocal of it, which is 1/2. And so in this general form, so I'm going back over here to this last column where I'm writing in red to find the inverse of A is its multiplicative inverse. You flip it 1/A. And when you multiply those together, they cancel out and they leave you 1. They don't leave you 0. They just leave you 1. And for our last property, distributive property, to distribute something means you give it out evenly, like everything gets it. So if you're giving out stuff, you're distributing it, you're trying to give every person the same thing. In math, that would look like this. I have something outside of some parentheses. And you could have addition in there, subtraction, whatever. And to distribute means that everything inside the parentheses is getting multiplied by the A outside. It gets distributed inside to everything. So that would end up giving me AB plus AC. And that's our distributive property. All right. So you have a worksheet to go with this with a bunch of specific examples. If you're going to be in class working, we're actually going to go over it together and hopefully be done before we leave. If you're working asynchronously, you can just try it yourself the first time and then go check the key with your assignment and post your pick. And I also have a Google form today for you to put your name and your grade on. So 2 things that have to go to this assignment: a picture of your work with your name and your grade written on it, and then also a Google form filled out with your name and your grade. All right, and then quiz on Friday. And yes, this will be on the quiz.